Hey, Algebra 1-B. Today we're looking at problem set 81, and we are looking at what's called graphical solutions. And this is where we're solving systems of equations again. And so far we've talked about substitution method and elimination method. Well, today we're looking at a third method of solving these types of problems, and that is by putting the two equations on a graph. Okay? When we put these two equations on a graph, we have three possible outcomes. We have what's called consistent equations. And when we have consistent equations, what this is where these two lines, when we draw them on the graph, these two lines intersect somewhere. Okay? And our solution will be this point where they intersect. Okay? So they could intersect in one point. A second option is these two lines could end up parallel to each other. And parallel means they never intersect. So on inconsistent equations, there is no solution. They don't cross anywhere, so there's no ordered pair that works in both equations. The third situation is what's called dependent equations. And what that is where I take these two equations and I draw the lines on the graph, and it ends up that they land right on top of each other. Okay? That is called dependent equations, and there's a whole bunch of solutions to those two equations because there's a whole bunch of ordered pairs that will work in both equations. Okay? The most common solution will be consistent equations. And something that we need to get used to, or to help us understand that, if two lines intersect in one point, in order for them to intersect, their slopes have to be different. So these guys have different slopes. We will get to some problems where it's just going to give you two equations and it just says, are these equations consistent, inconsistent, or dependent? And we start by looking at their equations and identify their slopes. If they're different slopes, I know they're going to intersect somewhere. Okay? In order for two lines to be parallel, their slopes have to be exactly the same. So inconsistent equations, they have the same slope, but notice they cross the y-axis in different places. So they have the same slope, but they have different y-intercept. Okay? On the consistent equations, they could possibly have the same y-intercept, but their slopes have to be different. Then dependent equations. These two are exactly the same line. So everything about them is the same. Same slope, same y-intercept. Okay? So same line. Now, most of the problems that we're going to see, they're going to ask you to solve by graphing. And so we need to put these two lines, here's our system of equations, we need to put these two lines on a graph. To be able to graph them, remember, you need y equals mx plus b. So step one is both equations need to be solved for y. So my first equation here, y equals negative 2x. I meant for that to be an arrow. So y equals negative 2x. This equation is solved for y. Right now I don't see a b on there, so I can always put a plus 0. So this first line crosses the y-axis at 0, and then has a slope of negative 2. Slope of negative 2, that's rise over run. So this line is going to go down 2 over 1. Down 2 over 1. And I can keep taking those stair steps down 2 over 1 until I get several points, and then I can draw my line. Let's make the line blue. So it starts down here. All right, so there's my first line. Second line, I'm going to draw it in red. This line crosses the y-axis at 8. It's already solved for y, so I have y equals mx plus b. My b is positive 8. That's way up here. Okay, then this line has a slope of positive 2. That's up 2 over 1. Now what you're going to notice here is I'm going to run out of room on the graph. If I go up 2 over 1, I'm already at the top of the graph. And I'm also going away from the line. My goal is I want to see where these two lines intersect. So one trick we can do, instead of going up 2 over 1, I can go completely backwards. And I can go down 2, back 1. And here. And down 2, back 1. I land on the line right there. I can keep going down 2, back 1, down 2, back 1. And then I get enough points that I can draw my line. And let's make it red. So here's my second line, and my goal is I want to see where do these two lines intersect. So I want to know that ordered pair. That's the solution to the problem. That's the same thing we found when we did substitution or elimination. So my ordered pair here, my x value is -2, y value is 1, 2, 3, 4, +4. So that's my solution. That ordered pair works in both equations. I would get the same thing doing either elimination or substitution, but we did it by putting the lines on the graph. So since these two lines intersect in one point, these are consistent equations. Okay? Let's try this one. Y equals -3x plus 4 and y equals 3x minus 8. We'll do the first equation in blue. So again, both equations are already solved for y, so I'm ready to put them on the graph. First equation crosses the y-axis at 4. 1, 2, 3, 4. Right there. And it has a slope of -3. That's -3 over 1. So down 3 over 1. So I get that point. 1, 2, 3 over 1. 1, 2, 3 over 1. I can keep making my stair steps. Draw our line. Blue. Pretty steep line right there. Okay, second line. We'll go red. This line crosses the y-axis at -8, so that's way down here. And it has a slope of +3 over 1. So I'm going to go up 3 over 1 this time. 1, 2, 3 over 1. 1, 2, 3 over 1. And I want to see where they intersect. 1, 2, 3 over 1. Okay, now a minute ago I talked about you can tell if two lines are going to intersect by looking at their slopes. If they have different slopes, -3, +3, those slopes are different. So I knew before I even started drawing the lines on the graph that they will intersect somewhere because their slopes are different. So let's finish drawing our lines and see if we can get that ordered pair. I can draw it from there because I just want to see where they cross. So my solution to the problem is this ordered pair where they cross. So those two lines, the x value there is +2, y value is -2. All right, so there's my solution. Again, these two lines intersect in one point. They are also consistent equations. All right, I put two more problems here real quick, just because you will run into these. It may ask you, state whether they're inconsistent or dependent or consistent. So first thing you need to do is solve these equations for y. Let's take this first equation in blue. Solving that equation for y, 8x plus 4y equals 16. To solve that for y, I need to subtract 8x. So that's 4y equals negative 8x plus 16. Always put that x term first, and then we divide by 4. So we get y equals negative 2x plus 4. Okay, now we'll do the same with the second line. Solve it for y. For this one, if I subtract 8x, I'll show that there, we get 4y equals negative 8x plus 8. Divide both sides by 4. I get y equals negative 2x plus 2. Okay, let's see what happens when we put these on the graph. Negative 2x plus 4. The y-intercept is 4. 1, 2, 3, 4. I'll go through this one kind of quick. The slope is negative 2. That's down 2 over 1. Down 2 over 1. Down 2 over 1. Draw our line. Let's make sure it's blue. So there's my first line. Now for the red line, it crosses at +2. And it has a slope also of negative 2. That's down 2 over 1. Down 2 over 1. That sounds very familiar. Down 2 over 1. Okay? These two lines have the same slope. So hopefully we remember what we talked about at the very beginning of the problem. When two lines have the same slope, They will never touch. So these two lines are parallel. And when two lines are parallel, this is called inconsistent equations. There's no solution to this problem. Inconsistent. Learn how to spell. Inconsistent equations. They are parallel. They'll never touch. Okay? Third problem here, final problem. Solve these equations for y as well. Start by subtracting 6x. Just trying to save some time here. I get 3y equals negative 6x plus 6. Divide both sides by 3. We get y equals negative 2x plus 2. Okay, time for the blue line. Solving this one for y, I subtract off 4x. That leaves 2y equals negative 4x plus 4. Divide everything by 2 to solve for y. We get y equals negative 2x plus 2. Okay, you should notice right off the bat, these two lines, these two equations are exactly the same. So when I put these two on the graph, they're both going to cross at positive 2. They both have the same slope of negative 2 over 1. So these two lines end up exactly the same. They land right on top of each other. Whoa, meant for that to be a line. Straight line. So there's the blue line. Red line ends up exactly the same right on top of it. So when two lines are exactly the same, these are dependent equations. All right, so we covered all three situations. Consistent equations, they have different slopes. They intersect in one point. They will have one ordered pair solution. We had inconsistent equations where the two lines have the same slope but different y-intercepts, so they end up parallel lines. They never intersect. And then the third situation is the two lines are exactly the same. They land right on top of each other, and they are dependent equations. Okay? Most of the time, you're going to have consistent equations, and they will intersect in one point. And that's our goal, is to find where they cross. Okay? This was a lengthy video. I hope it's not too confusing, but we'll just have to see. Okay? That's problem set 81. Good luck.